These are the frequently asked questions for Algebra 2, Section 9-1, Day 1, as we are starting to work on this chapter dealing with sequences and writing formulas for sequences. So these problems say find the first 6 terms of each sequence. And number 7 gives us the rule that to find any term, remember that a sub n stands for any term, we want to take 3 times n and add 2. So I start thinking about the fact that I want the first term. And I notice that I just replaced the n with a 1. So that means that I need to put a 1 into the formula for n. So 3 times 1 is 3, and 3 plus 2 is 5. And then for my next term, which would be the second term, I need to put a 2 in for n, and that will give me 6 plus 2, which is 8. For the third term, I need to put a 3 in to the formula. That's 9 plus 2, which is 11. And then for the fourth term, I would put a 4 in. 3 times 4 is 12, and 12 plus 2 is 14. And hopefully at this point you notice, wait a minute, 5, 8, 11, 14. Really, I'm just putting another 3 in there every time. And of course you are. Look what you did for n. It went from 1 to 2 to 3 to 4. And that's multiplication. So I will just get the screen down a little bit here so that I can put the 5th term on and the 6th term, because we notice that pattern from term to term is just adding 3. But we need to generate some of those numbers first to see that. Then number 11, we have the rule. A sub n, to find any term, take 3 times n squared and subtract n. So this is an interesting formula because you don't just use the n, the number of the term, once. We have to use this 2 times. So to find the first term, there'll be 3 times 1 squared minus 1. Well, 1 squared is 1, 3 times 1 is 3, and 3 minus 1 is 2. To find the second term, we'll need 3 times 2 squared minus 2. Well, 2 squared is 4, 4 times 3 is 12, and 12 minus 2 is 10. Third term, 3 times 3 squared minus 2, or minus 3. There we go. So 3 squared is 9, 9 times 3 is 27, and 27 minus 3 is 24. So I would look at this one and hope to find, that I'm just adding or subtracting something basic here, but from 2 to 10 we would be adding 8, and from 10 to 24 we would be adding 14. And of course this was a more involved formula about powers. So we really need to generate all of these in order to see what's going on. So 4 squared is 16, and 3 times 16 is 48, and 48 minus 4 is 44. And they wanted the first 6, so the 5th term will be 3 times 5 squared minus 5. 5 squared is 25, and 3 times 25 is 75, and 75 minus 5 is 70. And then the 6th term will be 3 times 6 squared minus 6. 6 squared is 36. 36 times 3 is 108. 108 minus 6 is 102. So formula getting a little more involved there as we move forward, having a power and using the n twice in the formula. Let me do some erasing here and fit number 13 on this page. So with this one, to find any term, we take 1/2 times the number of the term cubed minus 1. So if we want the first term, that's going to be 1/2 times 1 cubed minus 1. And 1 cubed is, of course, 1. So we get 1/2 times 1, which is 1/2, minus 1, which is a negative 1/2. Second term, 1/2 times 2 cubed minus 1. That's me thinking ahead to the next step already again. All right, so 2 cubed is 8, half of 8 is 4, and 4 minus 1. All right, we'll go after the third term. The third term is 1/2 times 3 cubed minus 1. 3 cubed is 27. 27 times 1/2 is 27 halves. 1 is 2 halves, so 27 halves minus 2 halves will be 25 halves. Fourth term, 1/2 times 4 cubed minus 1 equals 4 cubed is 64, and half of 64 is 32, and 32 minus 1 is 31. And again, this one has a power. You know, normally I'd say, hey, let's stop and check and see if we see the pattern, but powers, we need a little bit more experience in order to start recognizing those. So fifth term, 1/2 of 5 cubed minus 1, and 5 cubed is, of course, 125. So we're going to have 125 halves, and 125 halves minus, again, 1 is 2 halves, so that'll be 123 halves. And then for our sixth term, that will be 1/2 times 6 cubed minus 1. 6 cubed is 216, and you take that times 1/2 and you get 108, and 108 minus 1 is 107. All right, I'm going to go ahead and second cursives is we want to think about which term they are. And see if that's useful. First of all, you would just look up at number 17 and say, all right, are they just adding something? It's going up. So are they just adding something to each term, or are they just multiplying by something? Maybe there's something with powers you see easily, but we notice this doesn't have a quick addition type of answer to it. So we're going to go ahead and make this table. And with recursive, you always have to tell them a place to start. So we're going to tell them the first term is 0. And then we notice, well, they added 3, from 0 plus 3 to get 3. Then they added 4 to get the 7. And then they added 5 to get the 12. And then they added 6 to get the 18. And that's not a coincidence. So how do we tell somebody to do that? Well, we tell them to find any term. So A sub n stands for any term. We want to take the previous term, and now we want to see, is there a connection with the number of the term and what we need to add. So basically you're asking yourself, is there something simple I can do to 2 to get a 3, 3 to get a 4, 4 to get a 5, and 5 to get a 6? And yeah, that's something basic is just use n plus 1. That's it. So if they take the previous term and then add the number of the term plus 1, that will generate the term that they need. So again, it's just a matter of looking for these right now and looking for patterns. So that is number 17. All right, number 19. I'm not sure that we're going to go through all of that with this one. I am hoping that if I talk you through this, you might be able to see what they're doing. So we're going to go with the first term is 100 here, and then see if we can get away with no table on this, because I notice the numbers are going down, and it's not subtraction. But right away I'm thinking, well, they're taking a 0 off, and when you take a 0 off and it just keeps moving down by a decimal point, that's because you're dividing by 10, which is the same thing as multiplying by 1/10. So that's what I try. You know, I try, can I just multiply each term by 1/10? 100 times 1/10 is 10. 10 times 1/10 is 1. 1 times 1/10 is 1/10. And 1/10 times 1/10 is 1/100th. And there it is. So now I just figure out, how do I write that? So to find any term, what do? Well, you take your previous term and you multiply it by 1/10. And I'm going to put that 1/10 in front because it makes it a lot easier to see. And you don't necessarily need parentheses, but that might help somebody who's just starting out figure out, hey, that means they want me to multiply by 1/10 to get the next term. All right, we'll go to 22. And we have a 1, then a 2, then a 6. So I start thinking, okay, is this addition? Well, 1 plus 1 is 2, but 2 plus 4 is 6. And the addition piece just isn't working out. So then I think, all right, well, maybe it's something basic with multiplication. So 1 times 2 is 2, but 2 times 2 is not 6. Here we need to multiply by 2, then we need to multiply by 3, then we need to multiply by 4. So I realized I should put this in a table. This is one of those problems that's a little more involved, so it's going to help me out if I can see that n value and see how that figures in to everything that's going on with this sequence. All right, now remember what we saw was to go from 1 to 2, you had to multiply by 2. To go from 2 to 6, you had to multiply by 3. To go from 6 to 24, you had to multiply by 4. And to go from 24 to 120, you had to multiply by 5. Well, that's perfect, because that is n, and we can just use that. So again, we have to tell them the first term with recursive. You always have to say, hey, here's your starting place. And then to find the next term, you have to take the term number, which is n, times the previous term. So n times a sub n minus 1. And again, it wouldn't hurt to put the parentheses in there, but we kind of drop those later on when we know what we're doing. Because if you know algebra, you know that two things sitting right next to each other tells us that they're being multiplied. All right, number 23. So looking at number 23 and hoping that I can figure out what the pattern is, and again I notice they're going up. I see that it's not some simple addition, that it's not some simple multiplication. So I would again be thinking of my table. To set this up. All right, so I go back to addition and see if there isn't a pattern, and I realize, well, they added 4. 1 plus 4 is 5. 5 to 14, they added 9. And from 14 to 30, they added 16. 4, 9, and 16. Those are special. So I start thinking, what's so special about those? What could you do to 2 to get 4, 3 to get 9, and 4 to get 16? You'd square them. That's what you would do. So the first term is a 1. And then what we need to do is we need to add that n value squared. So we'll take the previous term and we will add the number of the term squared. So a sub n minus 1. I'm going to make that look a little smaller, more like a subscript there, plus n squared. And again, it's just reasoning your way through, but you can do that very easily with a table. And that'll be it for this assignment.